Hey guys, welcome back to my channel. So today I'm going to give you the 7th semester analysis question and answers as per RGUHS Question Bank. So there may be total 20 question answers for 10 marks which is given in the question bank. So I'm going to start one by one. So the first question, in the first question there are option A or B. You have to write either A or B. So the first question will be, describe and derive the equations of Beers-Lambert's law and add a note on the derivations and limitations of Beers' law. So the B question will be, write a note on theory and application of IR spectroscopy. Explain the different sampling techniques which is employed in the IR spectroscopy. So you have to write one, either A or B, but I am going to give you the both answers. So I'll start the first answer, that is Beers' law. The Beers' law states that the intensity of a beam of a monochromatic light which decreases exponentially with increase in the concentration of absorbing species arithmetically. So the deviation for the Beers' law is minus di divided by dc, which is directly proportional to the I. So minus di divided by minus dc, which is equals to ki, will be the equation 1, where k will be the constant, proportionally constant, and minus di or dc will be the rate of decrease of intensity of the incident light, that is I, with respect to the concentration, that is C. So rearranging the term of the equation, where the di minus divided by I is equals to k dc. So this is the equation 2. By integration both side, the integration will apply to the both side, and the log minus log I and kc plus b will be the third equation, whereas b is constant of the integration. When the concentration is 0, there will be no absorbance, or the I is equals to I naught. Then these are the equations we can put in the equation 3. Minus log I0 is equals to k0 plus b. So the fourth equation, or the equation, will be minus log I naught is equals to b. Substitution these values of the b value of the substitution will put in the equation 3, where the equation becomes minus log I is equals to kc minus the b will become minus log I naught. So the log I naught will come to the right side and the log I will move to the left, whereas the log I naught minus log I is equals to kc. Since the logarithm of log a minus log b is equals to log a divided by b, then the log I naught and I becomes the a and b, which will gives kc, proportionality constant, and the concentration, where removing the natural logarithm from the equation, where the I naught is equals to e kc, or making them inverse on the both side, will become I divided by I naught is equals to e minus k, or I is equals to I naught into e minus kc. This is the Beers equation. We are coming to the next, that is Lambert's law. The rate of decrease in the intensity of the incident radiation with the thickness of the medium is directly proportional to the intensity of the incident light, that is minus di divided by dt, which is directly proportional to the I, that is equation number 5. From equation 4, we'll take the I is equals to I naught minus e minus kc, that is Beers' law. In Lambert's law, the c can replace or reflect by t. So combining the equation 4 and 6. I is equals to IT into E minus KCT. So inversing for the both side, it will become IT divided by I, which is equals to E minus, the minus will gone because the inverse of the both side, then KCT will be the next equation. So converting the natural log to the normal, it will become the log IT divided by I, which is equals to KCT. The E will gone due to the normal logarithm, or the IT is equals to 10 KCT. The IT will divided by I, and ACT 10 ACT, where the A is K into 0.4343. So taking log on both sides, it will become the log IT divided by ACT, whereas log IT divided by A is equals the log IT divided by I is equals to A, which will become the equation number 7. So if the concentration is expressed in the terms of mole per liter, the equation 7 will be written as for A is equals to ECT, whereas A is the absorbance or the optical density, and E will be the molar absorber, and C will be the concentration for mole per liter, and T will be the path length of the thickness of the product, which is 1 centimeter. E is also be explained as follows, whereas E equals to E 1% centimeter into the molecular weight divided by 10, whereas E 1% 1 centimeter means the absorbance of the 1 centimeter 1%, or the wavelength divided by volume solution, which is using for the path length of 1 centimeter. Then the deviation of the Beard's law. So a system is said to be obey the Beard's law when a plot of concentration versus absorbance give a straight line, but the straight line is not obtained. So that is, a non-linear curve is obtained in the plot of the concentration versus absorbance, and the system is said to undergo the deviation of Beard's law. Such deviation can be a positive or a negative deviation. What is meant by positive deviation? So the positive deviation results when a small change in the concentration which produces a greater change in the absorbance, and as well as the negative deviation results when a large change in the concentration produces a smaller change in the absorbance. So several reasons for the deviations of the Beard's law as follows as instrumental deviation, physico-chemical changes in the solution, and true deviation will be the some points. And the theory, so the B answer, IR spectroscopy. So the theory and applications of IR spectroscopy. So the theory will be when the energy in the form of IR is applied and the applied IR take place and a peak is absorbed. So the molecule are excited to the higher energy state from the ground state when they absorb IR radiations. So when a compound is expressed to the IR radiations, is selectively absorb the radiation, which results in the vibration of the molecules of the compounds, which giving rise to closely packed observations or the bands, which is called IR absorption spectrum. And the organic compounds which absorbs EM energy in the IR regions, IR doesn't have any sufficient energy to cause the excitation of the electron and as well as the ultraviolet, whereas however they causes the atoms and the group of the atoms for organic compound to vibrate the faster and the concentration bond which connect them. So a molecule in its ground states possess three energies, that is electronic and vibrational and as well as rotational energy levels. Then the application of IR spectroscopy, the identification for functional group and structural, whereas in that some subpoints are given. So in a group, the frequency regions which peaks the corresponding to the different functional groups can be absorbed according to the corresponding peaks functional group and can be determined by each of the atoms or the molecules which is connected by the bond, and each bond requires the different IR regions. So the characteristics peaks are absorbed. This region of IR spectrum is called as a fingerprint region of the molecule, and it can be determined by the characteristics of the peak. So the second application will be identification of the substance, and the third application for IR spectroscopy will be studying the progress of the reaction, and the fourth one will be the detection of the impurities. So I may not explaining the applications for the IR spectroscopy, but you have to write down, because these are the 10 marks question. You have to explain what is the detection of the impurities, studying the progress of the reaction. So one by one you have to explain this. So just write out these answers, and the fifth will be the quantitative analysis. What will be the quantitative analysis in the IR spectroscopy, where the quantity of the substance can determined either in the pure form or as a mixture of two or more compounds. So if the drug substance is choose for the log, that is IO by IT, which peaks for the standard and the test sample which is compared, this is called as a baseline technique to determine the quantity of the substance. Where the other applications for the IR spectroscopy will be the study of the covalent bonds in the molecules, studying the progress of the reaction, detection for the impurities of a compound, ratio of cis and trans isomer in a mixture of compound, shape of symmetric and as well as inorganic molecules, study of presence of water in a sample, and measurement of paints and varnishes. So the second question will be describe in brief the principal instrumentation and application of gas chromatography. So what is the gas chromatography? It consists of a solid and as well as a gas chromatography, that is GSC, and the gas liquid chromatography, which is GLC. So the principle for the gas chromatography will be the separation of the GLC is a partition. Gas is used as a mobile phase and liquid is coated as a solid support, which is used as a stationary phase. So the component which is less soluble in the stationary phase will travel faster and elute out first. So the instrumentation for the gas chromatography will be a carrier gas, a flow regulators and flow meters, then injection devices, columns, temperature control device, detectors, and lastly recorders and integrators. So these are the important instrumentation for gas liquid chromatography. So in that, the number one, that is most important requirement for the carrier gas will be it should be inert. It should be available at the low cost and easily available or cheap and less risk for the explosion, and it purifies to remove the O2 and water in an organic traces, which will be the carrier gas system is also contains a molecular sieve to remove water and other impurities. So the other gases will be the nitrogen, helium, etc. Whereas number 2, that is flow regulator or a flow meter. What are the flow regulator or a flow meter? A carrier is stored under the high pressure to regulate the flow of the liquid or to regulate the flow of the gas, which is used to deliver the gas in a uniform pressure of flow rate. So the flow meters are used to measure the flow rate of the carrier gas, and they are rotameter and soap bubble meter. So the third is injection devices, whereas the sample is introduced into the injector through a safe sealing silicon rubber spectrum. So the carrier gas flows through the injector carrying vaporized solutes, and the temperature of the injector should be adjusted to flask which is vaporized. All the solutes will occur. If the temperature of the injector is not high enough, then the band broadening will take place. So number 4, that is columns. The columns are divided into 4 major groups. In that, the columns are divided into the 2 major groups, that is packed column and wall column. And last, detectors. The detectors will be characterized. They are ideally characterized or applicability to the wide range of the samples, high sensitivity to even small concentration, rapidity of response, linearity. Response should be unaffected by the temperature and non-destructive to the sample in the case of preparatory work, and simple and easy to use and easy to maintain, and they should be inexpensive. So the different detectors which are used commonly in the gas liquid chromatography is cathometer or a thermal conductivity detector, flame ionization detector, argon ionization detector, and lastly electron capture detector. So the last instrumentation for gas chromatography is recorders. They used to record the responses which is obtained from the detector after the amplification. So the applications for the gas chromatography, they analyze which is used to calculate the content of the chemical product, and isolation and identification for the mixture of the components. Gas chromatography is used extensively in the forensic science and checking the purity of the compounds, where the quantitative and qualitative analysis of some common drugs like amino acids, etc., are the applications for the gas chromatography. So the next question, third, in that A or B, you have to write A, third A or third B, but I am going to give you the both answers. Explain the principal instrumentation and application of UV visible spectroscopy, and the B question will be, what are the different vibrational modes of polyatomic molecules upon IR absorption? So write in the brief on the various detectors which are used for the spectroscopy. So the A answer, UV visible spectroscopy. The UV spectroscopy is concerned with the study of absorption and as well as the UV radiation, which ranges from the 200 nanometers to 800 nanometers. So the UV spectroscopy is a form of absorption the spectroscopy. And moving to the next, that is instrumentation for UV visible spectroscopy, source of light, filters and monochromators, sample cell, and lastly detectors. So the source of light, in that a tungsten lamp. The tungsten lamp will be used. The lamp consists of a tungsten filament in a vacuum bulb similar to the one which is used domestically. So the carbon arc lamp, for the source of very high intensity, carbon arc lamp can be used, whereas monochromators are having a following units like entrance slit, collimator, grating or prism, and lastly collimator, and lastly exit slit. So the prism is divided into two types, that is refractive and reflective, and as well as the grating is divided into diffraction grating or transmission grating, whereas prism and refractive type are having the same. The definitions for the refractive type and even the definition for the reflective type you have to note down. So grating are the most effective ones in the converting a polychromatic to the monochromatic light, whereas diffraction for grating have two types, that is diffraction and even transmission. So the definition for the diffraction and even the definition for the transmission grating are given below. Then the sample cell. In that, the sample cell, the sample volume is also an most important for the UV visible spectroscopy. And lastly, the detectors. The detectors are used in the UV visible spectroscopy. They are called as a photometric detectors. So there are four mainly used for detectors which is used in the UV visible spectroscopy. That is number 1, photovoltaic cells or barrier layers. Number 2, phototube or photoemissive cells, photomultiplier tube, and lastly the silicon photodiode. So if I am going to explain these all things, the video will get more longer, so please just write it down. I am not going to explain anything, just I am going to give the heading for the detectors or maybe the instrumentation, so you can easily copy down. And the third B question, the third A question was completed. Then the third B, different vibrational modes of polyatomic molecules. In that, molecular vibration can be classified by two, that is stretching and bending vibrations. The stretching vibrations have the two types, that is symmetrical stretching or asymmetrical stretching. So the symmetrical stretching atoms of the molecules either move away or towards the central atoms or but in the same direction, but asymmetrical stretching will be towards the central atom while other departs from atom. And the binding vibration or deforming vibration having the types, that is scissoring, rocking, outplane vibration, wagging and twisting. So in plane vibration, that is scissoring and rocking will be the definition which is given below, whereas the twisting for one atom which is moved up to the plane while the other down to the plane with respect to the central atom, whereas the vibrational frequency value stretching the frequency which bonds the Hooke's law and states the vibrational frequency of a bond which is directly proportional to the bond strength. And even the vibrational frequency is depend upon the bond strength, how the bond strength will be occur, the mass, and lastly the hybridization. Whereas the detectors which are used in the UV visible spectroscopy will be the thermocouples, bolometer, Guylok cells, pyroelectric detector and photoconducting detectors. So these are the definitions or the procedure for the detectors, which how they are used, when they are used and why they are used. This is bolometer. It is a type of the resistance thermometer constructed which is transferred from the ship and the metals such as platinum or a nickel. Then Gole cells, they are sensitive gas thermometer, and pyroelectric detectors, photoconducting detectors. And the next question, describe the principal instrumentation and applications for HPLC. So the principle for HPLC is separation in a normal phase mode and reserve phase, and made the absorption when the mixture of the components are introduced into the HPLC column. They are traveling according to their relative affinity towards the stationary phase. So the instrumentation for HPLC will be pumps, solvent delivery system, mixing unit, injector manual or auto injectors, then guard columns, analytical column, detector, recorders and injectors. So these are the instrumentation. Just note it down or copy to the book. I'm not going to explain because the video will get longer, much longer. Pump, in that the displacement pump and the other pumps are related to, and the mixing unit, the injectors, guard column, analytical column and even the detectors. In that the sub-detectors are used. Lastly, the recorders and the integrators. So the recorders are used to record the response obtained from the detectors after the amplification, and integrators, these are improved version of the recorders with some data processing capabilities. So the application for pharmaceutical application, number one, pharmaceutical application to control the drug stability, tablet dissolution study and pharmaceutical quality control. Whereas environmental application, detection of phenolic compounds in the drinking water or a bio-monitoring of pollutants. And the application for the forensic, quantification of drug in the biological samples, identification of steroids in the blood and urine, etc., determination of cocaine, and lastly the food and the flavors. So sugar analysis in fruit juices to ensure the quality of the soft drink. So the fifth question, same A and B. The question A and B, you have to write A or B, but I am going to give you the both answers. What is the essential components of UV visible spectrophotometer? Draw a diagrammatic sketch and explain the functions of working of each unit. So the essential components of UV visible spectroscopy is source of light, filters of and monochromators, sample cell detectors are the essential components for UV visible spectrophotometer, which is given in the question number 3A. So the full answer you have to copy from the question number 3A, whereas B question will be explain the theory involved in the IR spectroscopy with brief outline and IR spectroscopy instrumentation. So for these you have to refer question number 1B. Already I have explained in the question number 1B. You have to copy from the question number 1B. Now I am going to give the some other from 6. I am going to give you from 6 to 10 tomorrow or maybe day after tomorrow. If you like this video, please do like, share and subscribe to my channel.